All right, thanks for watching. This video is going to go over the solutions to Quiz 9 review. Here we go. So first up, we have a 0.5 kilogram rocket, accelerates upward. It has an upward lift from the engines of 40 newtons. So first up, we want to draw a force diagram. So we have our upward force here. Just call it FL for lift force. We know that's 40 newtons. And then we got the force of gravity as well. So it's a little model rocket, not a big, huge rocket. So let's just, while we're here, we'll find gravity. That's just mg, so that's just m is 0.5 kilograms, g is 9.8, and should get that the force of gravity is 4.9 newtons. Okay, so what is the rocket's acceleration? So to figure that out, you just sum your forces in the y direction. It's accelerating, so we put ma. And then, right, it's going to be the lift force minus the force of gravity. So we're solving for A, so leave that there. Let's see here. 40 minus 4.9 is going to be 35.1. A is equal to half. Divide by, or not divide by half, divide by 1/2. That's going to give you 70.2, which is a really big acceleration. However, it's one of those little model rockets, so they accelerate pretty fast if you've ever seen one. How high will it be after accelerating for 5 seconds? So this is a kinematics problem. There won't be one like this on the test, so don't worry too much about, or on the quiz, so don't worry too much if um, you're struggling with these still. But we have our acceleration, which we know is upwards at 72 or 70.2. We have our, let's just assume the initial velocity of 0. Um, where t is 5 seconds. And we want to know basically how high, right? So since we want to know displacement n time, that's going to be the John equation. Starts on the ground. Initial velocity is 0. Zero times by 5 is, of course, 0. So then we just have to do 0.5 times by 70.2 times by 5 squared, which is 25. And you get, it will be 877.5 meters up in the air. All right, there we go. Next one, draw a force diagram for the crate. So it is being pulled in that, we have a boy pulls a 45 kilogram crate with a rope. The rope makes a 28-degree angle to the horizontal, as shown right here. The boy exerts a force of 185 newtons. The force of friction, so there's friction on this, is 100 newtons. Obviously, we're going to have gravity acting on that. And there's also going to be a normal force. Make sure the normal force is less than that of gravity. Of course, the next thing to do is to break it into its x and y pieces. So, right, we take that and break that one. That one's going to be the 185, right? The force is 28 degrees. Cosine of 28, and this is 185 sine of 28 degrees. So what is the acceleration of the cart? Well, it's going to accelerate to the left, right? I mean, we can imagine this situation. We know it's going to accelerate that way, so we need to sum our horizontal forces, our forces in the x direction. set that equal to MA, and then we have the forces to the right, which would be minus the forces to the left, which would be the force of friction. It's 108 or 100. We know that it is a 45 kilogram object. We're looking for the acceleration. 185 times by the cosine 28 degrees is 163 minus the 100. So let's see here. Obviously, that's going to give us 63 on this side, 45A on that side. Divide by 45. And you're going to get 1.4 meters per second squared as your acceleration. Next up, what is the normal force? So sum your forces in the y direction. The forces in the y direction, up and down, the vertical, are going to be 0 because it's not accelerating up and down. We have normal force, which is positive. We have the 185 sine 28, positive because it's up. And I didn't even label this force of gravity, minus the force of gravity. We're solving for the normal force, so we can add the force of gravity to the other side. We can subtract the 185 sine 28 to the other side, and that just leaves you the normal force on the right-hand side of the equation. And so now we can kind of solve force of gravity. I believe it's a 45 kilogram. Yeah, 45 kilogram thing times by 9.8 minus, I'm just going to go ahead and 185 times by the sine 28 degrees is 86.9. So 45 times by 9.8, 441 minus 86.9 gives us that the normal force is equal to 441 minus 86.9. And that's going to give us 354.1 newtons. All right. Next, so now we have a block that's on an incline like so. Draw the force diagram for it. Obviously, you're going to have a gravity acting straight down. We got normal force is going to be kind of perpendicular to the ramp, so that's going to be up and to the left. The force of friction between the sliding block and the ramp is 10 newtons, so that's going to be in that direction. Force of friction 10 newtons. Let's remember that the force of gravity gets broken into pieces on an inclined plane problem. So that's our 19 degrees right there. This is going to be mg sine of 19 degrees, and this part's going to be mg cosine of 19 degrees. Says what is the acceleration of the block? So if it's going to accelerate, or like since it's accelerating in that direction down the slope. So sum our forces in the x direction, right? That's the x direction. And you're going to get ma is equal to, let's see, forces that are directed down the slope would be this one right here, the mg sine 19, because that's pulling the ramp or the block down the ramp. So it's going to be mg sine 19. And then we're going to subtract forces that are against that. The force of friction is trying to get it to slow down. So minus the force of friction. Again, we're solving for their acceleration, so let's go ahead and plug in our 20 times by 9.8 sine 19 minus the force of friction is 10 newtons. So 20A 2, so 20 times by 9.8 times by the sine 19 degrees is going to give you 63.8. minus the 10. Obviously, that's going to give you 53.8. And then divide by the 20, you're going to get that your acceleration is 2.69 meters per second squared. All right. So now we got the extra credit questions. This one's pretty similar to number 2, except that in this case, so we have a man pushes on a 60 kilogram crate. So we obviously have our force of gravity here. Somebody pushes on this with a 100 Newton force. We have our force, normal force, which has got to be extra big because the person's pushing down on it. And there's a force of friction, which is 40 newtons. Okay, nothing extra complicated about this. It's just an extra practice here if you need it. Let's see here. We take this 100 newtons and we break it into pieces. So that's going to become 30 degrees right there. This is 100 cosine 30 degrees, and this would be 100 sine 30 degrees. So then calculate the acceleration. So, right, it's going to accelerate to the right because he's pushing it to the right. So sum of the forces in the x direction is going to equal our ma because it's accelerating. We have 100 cosine 30 minus force of friction. Plug in our numbers. Let's see here. What was the mass of the crate? 60 kilogram crate. So 100. Let's see here. We can go and plug that in. 100 times by cosine of 30. That's going to give me 86.6. 6 minus, what did I say? The force of friction is 40. It's going to give me 46.6. So divide by 60. It's going to give you 0.78. There we go. That's your acceleration. Calculate the normal force. So the normal force is in the y direction. So we're going to sum our forces in the y direction. The crate is not accelerating vertically, so we put in a 0 as our net force. And then we got normal force, which is positive because it's up, minus the 100 sine 30, negative because it's down, minus the force of gravity, negative because it's down. So now let's finish solving. So we have 0 is equal to normal. Well, okay, hang on. We can move, let's first move stuff to the other side. So force of gravity can get moved to the left-hand side, as well as we can add 100 sine 30 to the other side, leaving us only the force of friction on the right-hand side. Force of gravity is m times by g, so 60 times by 9.8, so plus the 100 sine 30. 60 times by 9.8 is going to give you 588, plus 100 sine 30 is going to give you 50. 588 plus 50 is going to give you, normal force is equal to 638 newtons. So there we go. All right, one more left here. Let's do that. So we got, we have a, this is another inclined plane problem, a little bit trickier. Obviously, we have the force of gravity acting on it first. So it's an 8 kilogram block pulled up a hill, 25-degree hill by a 70 Newton force. So we have a 70 Newton of tension force that direction. Normal force is going to be perpendicular to the slope, so that's going to be in that direction. There's also a force of friction of 20 newtons, and gravity gets broken into its pieces. That's 25 degrees. So this is going to be mg cosine of 25, mg sine of 25. All right, well, that turned out to be kind of a mess, but here we go. Let's calculate the acceleration. So it is going to accelerate. Oh, that wasn't what I wanted to do. Okay, so it's going to accelerate that way, right? So we're going to sum our forces in that direction, the x direction, ma, because it's accelerating. Forces to the right would be, right, that tension force. Forces to the left in the opposite direction of the acceleration would be the mg sine 25 and also the force of friction. Let's go ahead and now start to plug in some numbers. So we got 8 kilograms for that. We got our acceleration. T is 70. We got 8 kilograms for M, 9.8 for G, sine 25 minus, we know that the force of friction is 20 newtons, so 8A is equal to 70 minus 8 times 9.8 times sine 5. That's going to give you 33.1 minus 20. So 70 minus 33.1 minus 20 gives you a net force of 16.9 newtons. Divide by A, or divide by 8, sorry, divide by 8. And you get 2.1 meters per second squared as your acceleration. And there you go. That's it. Hopefully you find these solutions useful. Obviously, let me know if you have any questions. But yeah, good luck. Thanks.